by the moon. They were becoming tidal. According to the latest theory from one leading chemist, these early tides may have been the trigger that kick-started life into action.
This seems like a very odd place to do some chemistry. Why are we here?
On the beach to investigate the effect of tides on chemistry taking place on the very early Earth, billions of years ago.
Professor John Sutherland believes that the ebb and flow of the tides played a crucial role in the origin of life. And he's going to show me how it could have happened.
We're going to do some chemistry here.
He's mixing up the sort of basic chemicals found in the first oceans and adding water. He's reproducing a tidal pool in his flask.
And that's your starting tidal pool at high tide. Then the tide goes out, the sun shines on the pool and starts drying it out. And rather than wait for that to happen here, it's going to take a long time. I'm going to speed it up a bit by using a burner here.
So what are we trying to mimic?
We're trying to mimic the power of the moon in chemistry on Earth. So the moon is responsible for tides. The tides are filling these ponds up. And then when the tide goes down, the sun shines, dries it up. It's an inexorable process of wetting and drying and warming and so on. And that is driven by the moon.
Having created a soup of chemicals, washed and dried them, there's still one thing missing.
I'm going to now transfer this into this other reaction vessel.
He exposes the chemicals to a blue lamp, which is radiating ultraviolet light that simulates the power of the sun on the early Earth.
This is just showing what the sun on the Earth.
And as a result, he's changing the very structure of the chemicals, creating, as if from nothing, elements of RNA, ribonucleic acid, an essential component of all living cells.
So we are, in this setup, making some of the building blocks of life.
Yes, just from simple tidal conditions and simple organic chemistry.
But it's all driven by the moon.
It's ultimately all driven by the moon. But life on Earth driven by the moon.
140 years ago, Charles Darwin wrote a letter to a friend suggesting that life probably began in what he called a warm little pond. At the time, it was mere speculation, but now we think he might be right. These tidal pools represent Darwin's warm little ponds. Primordial chemistry labs where the raw materials of life can come together, and all beautifully orchestrated by the tidal power of the moon.
Once the first creatures had emerged in the oceans, 3.8 billion years ago, evolution was in full flow. And ever since, the moon has continued watching over us, casting a protective veil.
When I was a teenager, I wanted a telescope so badly, mainly to look at the moon, but I couldn't afford a decent one. So at the age of 14, I went to an evening class and I learned how to make my own. Now, my telescope worked on a similar principle to this one, using a mirror to reflect the light. It took months to grind and polish those mirrors, but it was so worth it. I remember the first night when I pointed the telescope up at the moon and I could see the craters in amazing detail. And the first thing you notice is you're always looking at the same craters. This is because the moon spins very slowly, one rotation every 29 days. And that's exactly the same speed as the moon orbits the Earth. So as the moon travels round us, it's always showing us the same face. So we never see the far side or the so-called dark side of the moon.
If we could, we'd see that it's riddled with craters. In fact, we now know there are more craters on the far side of the moon than the near side. which is a bit of a relief, because each of them was formed by an asteroid impact that could otherwise have crashed into Earth and stopped life in its tracks. The moon, which helped start life, may also have preserved it. Our guardian angel. This idea that the moon looks after us is ancient. 5,000 years ago, people on the Outer Hebrides shaped these rocks into megaliths and placed them in a great circle. They didn't have metal tools, let alone cranes. It was a remarkable thing to do. All the more so as it seems they were building a sort of observatory to mark a rare lunar event.
Every 18.5 years, the moon drops in the sky for a couple of weeks and barely makes it above the horizon. It's known as a lunar standstill, and it last happened in 2006, and it won't happen again until 2024. Bizarrely, the people who built Callaniche probably knew about the lunar standstill, and they aligned their stones to witness it. From this angle, you can see the moon rise above those hills over there and drop between those stones. It must look spectacular.
To line up the stones accurately, they could only check their position every 18.5 years, at the next lunar standstill. It seems incredibly complex, so why do it? Across the ancient world, people revered the moon and made up stories about the mysterious power of this disk in the night sky. Some stories have survived the test of time. Think of the classic werewolf movie. It's all about the strange, terrible magic of the moon. Even today, it's often said that the full moon casts a spell over us. It sends us a bit crazy.
It's Friday night and I'm out with the police. It's always a busy time with people partying in clubs and bars. But tonight is also a full moon. Does that make any difference?
Over the years, there have been many studies which claim to show a link between the crime rate and a full moon. They suggest that people become wilder and more violent when the moon is full. It's called the Transylvania effect. One police force in the south of England was so convinced they put extra officers on the beat at a full moon, just in case. But is it true? Does the moon really change our behaviour?
Well, sadly, I don't think so. For every study claiming an effect, there are many more dismissing it. The theory probably stems from the fact that when the moon is full, the sky is much, much brighter.
In the past, before electric lights, people were more likely to go out on a bright night, so there was more chance for trouble. These days, alcohol is surely a far more important factor than the light of a full moon. But even if the Transylvania effect is a bit of a myth, the moon is still very powerful. There are many animals which react instinctively to the light of the full moon. They become more active, more vocal, more fertile. Most remarkable of all are these tropical corals. Every year, they synchronize their reproductive cycle, so on one night, they all spawn together. And that night is triggered by the full moon. The Sargasso Sea, off the coast of Bermuda. Marine biologist Dr. Anne Cohen is studying how the moon affects the growth of corals. She's looking for a species known as Diporia strigosa, the brain coral. Every 29 days, on a full moon, brain corals grow a new layer of skeleton on top of the old. This growth spurt is dictated by the monthly orbit of the moon. It's like clockwork. And the skeletal layers can be used as a lunar calendar, a record of time passing.
So this is the coral that we pulled out of the water today. And if we look under the microscope, you can see very fine ridges. And we know that these are formed on the lunar cycle. These are monthly bands.
Okay, so it's a bit like the rings of a tree. You can use that to date it.
That's right. And actually, we can count about 65 monthly bands
Oh, right, yes.
in this coral, which makes it just over 5 years old.
That's pretty amazing.
But
some corals are even more revealing. They allow us to peer into the distant past and find out something extraordinary about the power of the moon. This is a fossil coral from the Devonian era. It's 400 million years old, but still beautifully preserved. As well as monthly growth bands, there are annual bands, and even daily bands, 1/4 of a millimetre apart.